Hello geeks. I hope you guys are doing well. Today we are here to learn about a very new chapter, that is basic problems on bit manipulation. So these chapters will consist of the videos which are solely focused on the bitwise algorithms, right? So stay tuned and let's move further and analyze the world of bitwise algorithms. So here we go. So there is a certain problem given to us. A number is given, that is n. Your task is to check whether the given number is a power of 2 or not. Very pretty simple. If the number n is equal to 4, you know that yeah, 2 square is 4. So the output will come yes. If the certain user gives the input 7, you know that it's not a power of 2, so your output is no. If n equal to 32, you know it's 2 raised to the power 5, so your output is yes. Simple. There is a layman algorithm in which you can easily find out the solution. But how do we solve it using bitwise solution? Let's have a look. So if we subtract a number which is a power of 2 with 1, then all of its unset bits after the only set bit becomes, and this set bit becomes unset. So what does this mean? Suppose if you consider a number 4 whose binary representation is 100 and 16 whose binary representation is 1000, that is 1000. It's not called 100, basically it's called 100, and the binary representation of 16 is called 1000. So if you subtract 1 from them, what do you get? Of 4 you get 0. After subtracting 1, after doing the bitwise subtraction, you get 0 1 1 after subtracting 1, so that's 3. And subtracting 1 from 1000 gives you 0 1 1 1. Okay, that's 15. So how do you determine if a number is power of 2 or not? You can use the bitwise AND operation. So if n is a power of 2, then n bitwise AND n minus 1 will be 0. So the AND operation of 3 and 15, if it gives 0, then the number n is a power of 2. Got it? So if n is a power of 2, its binary representation has exactly one set bit to 1. Subtracting 1 from n flips all the bits after the set bit, including the set bit itself. So the bitwise AND of n and n minus 1 will be 0 if n is a power of 2. Suppose if you want to find out whether a number 4 is a power of 2 or not, what do? First, what do? You take the binary representation of 4. Simple, don't go through all this, just listen to me what I am speaking. What do? Consider 4 a number, you write the binary representation of that number, that is 100. What is n minus 1? That is 3. Write down the binary representation of 0 1 1. Do the AND, the bitwise AND operation. If it's 0, if the AND is 0, then the particular number is a power of 2. Simple. So no need to go to the loop, no need to put certain conditions. Within a simple bitwise operation, you can do it. Another problem we do have. So given a number n, you have to find out the most significant set bit in the given number. What is the most significant set bit? How do you do it? The MSB. You know what's MSB? That is most significant set bit of a number. So you have to calculate the position of the MSB by finding the base 2 logarithm of n. So if you find out the base 2 logarithmic value of n, you get the position of the MSB. So how do you do? Let's have a look at the example. So suppose the input n is 10, output is 8. So the binary representation of 10 is 1010. The most significant bit corresponds to the number 8. So you have to find out that the position of that MSB by finding out the base 2 logarithm of n. What's base 2 logarithm? Log base to the power, log base 2 actually. Or you can do it in another way, that is 2 raised to the power of the calculated position. And this technique we learned in the previous problem. How do you find out if a number is a power of 2 or not? Simple. Problem 3. You are given a number n. You have to find out the XOR of all numbers from 1 to n. What's XOR? It's exclusive OR. So let's have a look at the example. N is equal to 6. So your output will be 7. Why? Because 1 XOR 2 XOR 3 XOR 4 XOR 5 XOR 6 will give you 7. If your output input is 7, your output will be 0. How do you do it? What's the solution? How do you find out? So you have to find out the remainder of n by moduling it with 4. What's moduling? That's modular division. So find out the remainder of n. If remainder is 0, then XOR will be same as the number n. If remainder is 1, XOR will be 1. If remainder is 2, then XOR will be n plus 1. And if remainder is 3, then XOR will be 0. Got it? So, how do you do it? So, suppose n is equal to 7. Okay? So, you have to do the modular division by 4. So, 7 divided by 4 will give you, the question will be 1 and the remainder will be 3. So, you got the answer 3. So, see, in the last section it's written, if remainder is equal to 3, then your XOR will be 0. Direct your answer is 0. Simple, no need to do the XOR, no need to find out the bit value of all, then do the XOR. No need to do it. Again, let's see. If n is equal to 6, do the XOR with 4. I mean, do the modular division with 4. So what do you get? The remainder you get is 2. So if your remainder is, you get is 2, then your XOR will be n plus 1. So n value is 6. 6 plus 1 is 7. Simple. So if you know this small tactics, don't need to go into the loop. You can easily get through the course. Got it? And it helps you in your online assessment as well. So I hope this entire PPT was understandable to you. Don't worry, this PPT will be there in the description section. You can always refer it, and I hope this was really clear to you. And stay tuned for the upcoming chapters as well.